Behind me is QA1, all of the manufacturing, assembly, packaging, testing, all that, and best of all, they got a basketball court. Let's go look at car parts. Hey guys, welcome back. So we are currently at QA1. We've been trying to make this trip for like 2 years now, but it's pretty exciting. We get to go through and show you all the good stuff that's happening back there. We've ran QA1 mod series shocks, QA1 drive shafts, all kinds of different good QA1 stuff for quite some time now. And we finally get to see where it's all made at.
It's impressive, isn't it?
I mean, we just walked in the door and I'm already stealing shop ideas here.
I'm really envious, jealous. It makes me realize how small we are in this world. But it's super impressive. I can't wait for you guys to see what's back here.
All right, let's check it out.
All right, so this building, we built this building, we moved in January of 2020.
Okay.
Right? And it was really a great opportunity. There were some pain points for our old facility, which was great, just a couple miles down the road. But we were able to take all of those pain points, whether it be different buildings on different pieces of property or just different manufacturing constraints, alleviate all those pain points here. So, pretty cool.
Kind of learned the hard way.
Oh yeah, exactly, right? But this area, this is customer service, kind of home base. So if you call QA1, phone call comes in right here. And our standing statistic right now is, you call, we will pick up within 37 seconds.
Oh wow.
That's impressive.
That is impressive.
Because there's nothing more frustrating when you're in the middle of a project and you get stuck and you call, and then now you're 2-3 hours out on some kind of information.
No, it's actually a top line metric we look at on a daily basis, and these guys, they'll pick up, they'll help you through your project, get you going, and you're on it.
That's impressive.
There's some other companies out there that don't have that track record.
37 seconds.
And it speaks volumes on the internet. I mean, people.
Yeah, that's
really,
awesome.
Yeah,
that's right. That's cool.
Yeah.
That's
I've never had to call though, so I don't know that.
Well, there you go.
That's news.
It's
Okay.
so good.
All right, back in the back.
But out here, this is where the magic happens. This is the part I love. So, out here, the manufacturing operations, when you look at a QA1 part, it's built right here.
All of it right here.
That's right. So, everything from tube bending to laser cutting to CNC operations, we run this facility 24/7 lights out.
Oh, really? So all constantly. So you have multiple shifts that come in.
Oh yeah.
And they're just cranking parts out.
Yeah. So we run 2 shifts, and then on the weekends we run a skeleton crew as well. Because really the big thing for us is we need to keep the material going into these machines, right? Yeah. So when we're talking the shock absorbers, like the mod series like you're running, we'll be running those right down over here. So let's go walk around and show you around.
This is your,
I guess.
Yep.
This is your kind of area.
It is. This is my thing.
Yeah. So right now we're bending up some sway bars. So we'll be running chromoly sway bars pretty much every single day. We'll also be doing some of the different weldments and some of the bending for could be like a subframe or part of like a K member or something like that for like a Mustang. Oftentimes will be getting done through there. But all the bending operations, we'll be doing that right there.
I'm curious, is it necessary to heat treat that after it's been up, or is that?
It depends on the usage, right? So typically with a sway bar with chromoly, that's not going to be as much of an issue. But for some other applications, that's something we do need to consider. So that's a good question.
And that's all CNC right there. I mean, he's loading that bar, and it's bending the whole sway bar without him touching it.
Yep, it's all pre-programmed. So we have a whole engineering team backing that. So all of our manufacturing engineers, they're helping design those bend paths. And you'll see that as well in some other areas, especially if you get over to welding, what the team needs to do to program those weld paths.
And that's not mandrel bent, that's just a bender, right?
Correct. Yep, you got it.
That's
you got
cool.
And then
link.
Yep.
The guy bends it, the machine, he loads it, the machine bends it, and he sets it in his jig there, and it just fell right into place. I watched it, everything just falls right into its socket.
That's awesome.
We'll do CNC press braking as well.
Look at that.
So, and this is thick material.
That is.
Oh,
Look
wow.
at that.
That's 9/16 or something. That's
Yeah, I'm
thick.
not even sure what this one is used for specifically. Because oftentimes we'll be doing fixtures and different pieces for, could be things that we're building for other applications. So
all that CNC backdate, so he makes a bend and then it repositions back there and he makes the next bend. He doesn't have, it's not like what I do. I got to draw a line and bend it. That's why everything is perfect here.
Yeah, that's
perfect.
That's cool. But the thickness by itself,
It blows my mind.
it's pretty rad.
So, we get a lot of sheet material, flat stock in this, fashion right here. This is our brand new laser that we just got. We kind of outgrew.
Brand new laser.
That's a big laser.
We outgrew our other one, but this kind of gives you a perspective how, we'll be taking different brackets, so we'll be cutting them out right here.
Oh.
So, and we'll be doing, 5/8, oftentimes, so some really, really thick material.
Wow.
But it cuts really nice. We can send this off, be press broke, send out powder coat right out of the gate. So, we try to control as many of those operations in-house as we possibly can.
That's also got to help with time, and that way, like, if you guys know where it's at in process, that's got to help with actually getting stuff out in a timely manner.
Oh, totally. Yeah, and we'll be looking at flow too from department to department as well. So, yeah, we'd be doing quite a bit of that.
That's a hard job.
So,
I'm so envious. I want that so bad.
Dad, I'm getting building ideas. Dad's getting machine ideas right now.
You're getting what ideas?
Building ideas.
Oh, you gotta have a building for the machines, but the machines is the precision.
True.
I mean, that's obviously four-link brackets. And look at, they're just gonna be, everyone's exactly the same. So perfect.
So this would be an example of like some of our classic truck kits. This would be actually the frame brace that goes across the back before you do your C-notch.
Nice.
So this still needs to have some bending done to it as well, but this would be a piece that we cut right here.
So that's a fixture?
No, this would actually
That's
be
actually the side of the frame? Or?
the side of the frame,
Okay.
right. And then we'll come in, everything's all keyed, so we'll be doing some different bending and notching and welding to this, and then we'll send this off and be powder coated still.
You get to see that bending process.
Oh yeah, right over here.
I wanna see that. Because it's multiple steps there. I mean, it's not an easy bend,
Right.
but they make it look so easy.
Also, guys, if we look awkward holding this mic, it's because it is. Because he doesn't have one. He has one, so bear with us.
I could shut up.
No,
it's so interesting. I could talk about it all day, and it's probably not what we need to do.
Yes, it is.
Okay. Good.
I like this whole area here, which this I assume was probably when you switched over to the new facility, having this set up and like the best flow. That's probably part of it, right?
Well, a big thing, and this sounds simple, but when we came into this new facility, we put up as few walls as possible, right? That was something with our old facility. It was a great place. We did a lot of great manufacturing there, but we had a bunch of different rooms. And those walls and those rooms didn't allow us to expand or move around like we wanted to. This CNC department, in a few short years, we've moved around quite a bit, right? And not having walls just gives us that flexibility.
Totally makes sense.
It's a very simple thought process, but it pays big when it comes to, again, how we're trying to set the facility for flow.
Well, it makes it a more friendly environment too for your workers. I mean,
Oh, yeah.
you can see everybody. If you're isolated in a section, it's not going to be as good at work.
Yeah.
I mean, people aren't as happy.
Well, even look at like, big natural light coming through and stuff like that. You don't get that in a lot of manufacturing facilities.
Yeah,
So,
no, that's
really
nice.
cool.
yeah.
And then I guess you guys just move around like as you figure out, well, this would be faster doing this. Is that kind of the reason for moving that around?
Yeah, so efficiencies or new equipment, right?
Okay.
This is an example right here. So this is where we're doing our shock bodies. So the outside cylinder that you'll see on the shock, it starts with bar stock. We used to run 4-foot bar stock for our shock bodies. We've graduated to a 12-foot section. And so we had to completely redo this pad and get it set up so we can run this longer bar stock that you see here. So it was efficiency gain that we saw, and it's, again, just kind of continual improvement mindset.
So you're taking those bundles and loading them right here.
Exactly.
And then feeding them into that machine.
Yes. Yep.
And you have to pour a big slab.
Yeah, so this is all poured super thick. We gotta keep the machine stable. That's a big thing. So what this is doing right now is, that's a shock body that you'll see on the outside of a lot of QA1 shocks. So we'll do both the ID and the OD right here. And then we work with a local company. We'll send it off and have it clear anodized. So that way it doesn't, oxidize or change, with corrosion.
So it's anodized inside and out. So
Yes, correct.
Does that help with the wear, like the piston?
Well, actually, it's going to have a compression tube inside oftentimes that the piston's going to ride on. But depending on what type of environment that you're driving in, like salty environments and stuff like that, we just don't want that raw material. We want it to look good for a long, long time for you. And up here in Minnesota, we got a lot of people that drive their cars throughout the entire winter months. So
all that salt getting on.
yeah, the chemicals and everything that we spray on the roads.
It just hurts my feelings when I get a pair of mod shocks. It's so perfect.
Oh, yeah.
They're like artwork, and then I have to turn a thread on here and scratch them up.
Oh,
and,
sure.
You know, that's literally artwork for somebody like me.
no, that's nice.
Look at the threads.
Very fine.
They're so fine and so perfect. You know, if I cut those, it would be rough.
Oh yeah, totally. But if you think about it, this is a relatively simple part, right? And we're taking that painstaking effort to actually machine that right here in house.
Right.
So
where you could outsource or
we could,
something,
yeah.
but you're keeping control.
Yeah, we're keeping the quality, the control. We're controlling our destiny too, right? So we want to make sure that we're continuing to build shocks each and every day and get stuff out the back door, and you know
that could come in a box with China stamped on the side of it, cheaper for them.
Yeah.
But there's no way that they would have the quality or control of that.
That's awesome. That's
so, but yeah, that's something that this machine is turning every single day.
And this robot here, I guess, is taking parts off of that.
Correct. Yeah. And we have built some robotics into the facility in different areas. This was one of those areas that we saw an opportunity for. This machine will turn out a shock body every couple minutes, right? To have an operator stand there and unload the machine, it's not enough time where they can step away and do anything meaningful, but also not an opportunity for them to stretch themselves or try to do something a little bit more challenging or kind of stretch that individual. So we put robotics in where it makes sense for
It's not really taking a job away from somebody. It's taking some boredom and mischief away from somebody.
No, and I think that's a really good point to highlight, is it allows somebody to, again, stretch themselves, but also each one of these pieces of robotics, there's an engineering team behind it. There's a team of people that need to program that. In some cases, you might be adding 3 positions just to support something like this. And I think that's an important thing, especially in today's day and age, when we're seeing computers and robotics and AI and different things start to be incorporated into workflows. There needs to be a person helping come up with the creativity of how this can be used.
That's right. I mean, and a lot of people don't think of it that way. A robot's taking jobs away, but it's not really. No. I mean, not this case.
At the end of the day, I wouldn't want that job.
No.
Standing there, so like
how long is somebody going to do that before they're off to something else?
So that's cool. That's a good place for it. That makes sense. That's cool. I like that.
I just need robots.
You need robots?
I do. And lasers. And vendors.
So each and every day we're making a lot of chips. Over here we're building right now shock bodies. So these are our double adjustable shocks.
Yeah, that's nice.
So these are being machined right here. Now if you were to compare the intricacies over there, that shock body, and now start to look at what we need to do for something like this, I mean, it's really a work of art.
Is that, because that's a is it all done in the machine and just rotated?
Yep, it's a single op, so it's a solid piece of bar stock. And so this machine here will be coming in and not also turning the OD, but it'll be going in and milling some of the different sections. We'll be drilling all the fluid ports and how the fluid needs to move through the shock. You'll be threading as well, some of the ID threads, so that pieces can screw into it and interface with it. So there's really quite a bit happening in there, especially if you look at these mill flats and everything.
And when it cuts it loose, it's all done in one operation.
Exactly,
it'll
fall off.
This is the last end of it.
Exactly.
Here. And so when it drops off, it's got basically nothing supporting it. It cuts that off and drops off. Does it drop off?
Yeah, so actually, if we look inside, I know one button, it's the light button. So it'll actually start machining on this end over here, as you can see, on the left side. And then on the right side, it has another collet. It'll come in and grab it from the other side.
Okay, that's when it cuts. There'll be a little bit of waste on the end of it'll drop.
And then when it moves over to the right side, it'll actually come back and machine that final side.
Okay, all done right there. Look at that.
So
that's
if you can
amazing.
see it, it's coming in and grabbing it right now.
Is it actually performing an operation there when it's slow like it is? Or is that just a switch over?
Right now it's mostly switching over. But that way, since you do have the the two different turning heads, it allows you to grab it from both sides.
So it just cut that piece off of that
Yep.
long bar stock, and now it's finishing the end over here, the round
Exactly.
end.
That is so cool. There's actually two whole machines going
or
in
three.
there.
I mean, you can call it three, I suppose.
That is a
Drilling, everything.
that is a complicated machine right there.
And it's listen to it, or don't.
Don't listen to
Yeah,
it.
there's nothing to hear.
Okay, that's cool.
Beautiful.
That's cool.
Yeah, so
Having in-house stuff
you know
is
everything from
really
the shock bodies. We'll be doing pistons, we'll be doing the glands, different internal components. But again, we're trying to do everything that we can to, on those dimensionally critical pieces especially, control that destiny in-house.
Is that machine there dedicated purely to doing that part, or do you have to cycle in and
A
out?
lot of machines will have their kind of areas of specialty where they're commonly doing similar operations day in and day out, but there's enough flexibility where they might be doing different things at different times.
So does each shock that you're running, that thing's going to be running those double adjustables all day. But is that a mod shock as well? Or
That'll do mod shocks, that will do single adjustables. We have non-adjustable shocks as well.
So you don't have a machine set up for singles and then that's running doubles. That one will actually change to another style shock.
They'll change back and forth,
Okay.
yeah. But some will have specialties or the volume requirements. Some machines will just run that all the time, depending on what we need at a different point in the year, right?
Is this basically Morsiki? Is that, DMG Mori, is that a Morsiki machine?
That's a great question. Nick over here might have a better answer. Say, Nick, I'm giving a tour. DMG Mori, can you give a background on that?
Is that a Morsiki? Is it a offshoot of them? I'm not familiar with it.
So Dr. Mori and DMG, Morisiki used to be his own, and then they combined with DMG and Dr. Mori, and then it became DMG Mori. From what I know about.
Okay, so Morsiki doesn't even exist anymore then?
Correct.
Okay. Wow, what a beautiful machine.
Yep.
Look at that.
So Nick
Nice. No,
leads.
it's nice.
Nick leads a lot of our programming efforts here in CNC. Racer himself, late models primarily, so both dirt and asphalt over the years. But one of the things with QA1 is we have enthusiasts baked all around the facility, right? And for someone who's setting up some of the machine paths and really looking at the critical dimensions of what a shock needs to be to perform, having guys like this, kind of the front and center of that is really important.
Yeah, it's nice to have the guys that are using the products,
Oh yeah.
designing and making the product.
Yeah. I mean, you've brought back feedback that's actually gone into production changes to some of the parts.
Yeah, for sure.
Yep.
That's cool. So, that makes a big difference.
Oh yeah.
Your people are real car people.
Yep.
So,
Josh here, he's a hot rodder. He's got what year is your Tempest, Josh?
64.
64
Also have a Le
Tempest.
Mans as well,
Yep.
and then Bonneville 60.
Yep.
Yeah.
is that the one with the transmission built in the rear end?
No, just prior after the first year GTO.
Okay.
First year. Yep.
I'm trying, guys. No, that's really cool. That's what they were saying when I was talking to them earlier. There's everybody here has some kind of different background, whether it be dirt racing, street car, whatever, drag racing. So that's rad. That's awesome.
Some of us get to say that we've actually had our car in the shop for research and development purposes.
Are you
and
one of
they've
those?
installed things on them.
So you're one of those.
Yes. Yeah. What an improvement. Oh. Yeah.
So that's a side benefit.
That's
Some people get
performance.
insurance and they get all of it. They get the cars over here.
Vet performance without the vet cost.
I like it.
That's awesome.
And made in the U.S. right here.
That's the best part.
That's what we're checking out right now is the fact that it's all. He's loving getting to see all the machines.
People have to understand the difference. You can import all this stuff on a ship, but this is not. That makes it worth it. Just pay, even if it costs a little more. Who cares?
And then having people that get it. So, okay. Sorry for the lack of microphone skills, guys. I'm trying. Thank you, guys.
So this is a newer 5-axis that we've put in. It's done several different ops for us so far. Like a lot of our strut bases, we need to have kind of more of that clevis style mount. You have to machine pieces like that. That's very intricate. So this 5-axis allows us to do that. But also it allows us to do some operations that just allow us to really design the products and look that much better. So that's something that has been a fun expansion for us over the years. I'll show you where then the shocks that we saw, the components that were being machined, where then they come together for assembly, which is really neat. So not only are we focused on the CNC operations that we're doing, we're then doing quite a bit when it comes to the actual assembly aspects of what we do. So here's an example, that shock base we saw earlier, right? So we've sent it off, it's been anodized now, and we'll start sub-assembly on some of the components. So each of these stations have a different job, and what we'll do is we'll do sub-assembly, which then each of the sub-assemblies will make their way up to wet assembly. So we'll fill the shock with oil. There'll be a mixture of both manual and then some robotics again. The final robotic step is we'll actually have a machine cycle the shock back and forth, purge all of the air out of the shock so that we know that we have the right fluid levels, there's no air pockets or anything that will change the valving. And then when we're done with that, every single shock that we do gets dynoed. So kind of like when you're dynoing a car, right, horsepower and torque, we can see at different speeds and velocities how much force the shock is making at different clicks, right?
Are you basically verifying that the shock's good? I mean, because
100%.
so I mean, they're CNC. How can they be different? How can you have a bad one? They're so perfect.
It's amazing because you can get a little bit of debris. You can get maybe some cardboard fiber or some things that get stuck between the piston and the deflected disc. You might get something stuck down on the base, but things happen, right? But by dynoing the shock, and we'll test it at different valving settings at different speeds, we can see any of those small variances. We'll pull that shock off, send it to the back of the line, and we'll figure out what happened.
So when somebody gets a shock from you, that thing's proven. I mean,
yeah,
you know
totally.
that it's going to be right out of the box.
And it'll be the same shock today as it will be 3 years from now, or over the course of time. So if someone's trying to set their car up and they know on setting number 8, my car will do this, well, another QA1 shock will do that same thing for you time and time again.
Yeah, that's a big deal.
Yeah.
Like when we just ordered injectors, we really wanted smaller ones because we don't think we need that big one, but we'd have to retune for it. They can put a shock on 3 years from now and set the same clicks and go make a pass.
Right.
It's going to do the same thing.
Yep, 100%. So we'll laser every single day then the collision nut that goes on top of that shock. So it tells you not only what the shock is, it gives a serial number, so if we ever want to go back and look at that shock, when it was made, how it was made, things like that, we have documentation on that. And then of course that made in USA that people are proud of when they see that shock.
That's very cool.
So
that shock it's never a mystery. It's serial number.
Is that something that if somebody wants that information, they just call in, or how do they?
If they want information on that shock, they can do that.
And they just reference that serial number and.
Yeah,
that's cool.
Absolutely.
That's cool.
Wow. So, but yeah, we'll laser them each and every day.
They have nothing to hide. Seriously. I mean, if you don't number them, you got an excuse built in, as you call it, but they've got everything serialized.
Yeah, and it's one of those that if you're buying a part off the shelf, like it's brand new, it's easy to know what that is, but then you might buy it from somebody else or trade it or find it over there and run into it all the time, especially at Hot Rod Garage, where it's like, don't know what that is, can't find a label on it, don't know the number, now it's no good for me. So that's an important feature.
That is cool.
Yeah, we get that a lot. Someone will buy a car, they're looking for information on what is on that car. So yeah, really good point.
This may be off camera, but do you do rebuilding?
We have authorized service centers that do the rebuilding. So we have a network of people that work with us around the country that might do custom tuning for someone that has a very specialized need. Or if they're just getting their shocks freshened up ever so often, that's something that can be done.
We don't do it here.
No, we try to keep the focus on the manufacturing aspects of what we do over here. But that's something that, we have a great team that is, again, anchored all over the country, and they can help people out with that. This is something that I've always found really neat and kind of fun to talk about, is these little tiny shocks here, they're not for the go-fast hot rod market in the least. We have a variety of customers that come to us at any given time and say, hey, you guys know shocks. We have an application that we need help with, and we're able to help extend our expertise into other markets. So these shocks specifically actually get used on a mobility chair, right? So for the healthcare market, but we might have someone that comes to us in the egg market or lawn and garden, or small scooters and vehicles of different types that need shock absorbers. That's a big part of what we do, but it doesn't get seen all that often.
It's not what you're known for.
No.
But you're helping a lot of people out.
Yeah, so a lot of different industries. So, it's kind of a fun way to have our engineers stretch themselves in some new ways as well. So not only the Go Fast parts that you guys use, but also many other industries and some that seem to surprise me every single day.
Well, I was going to ask, because doing something in a different field that you're not used to doing every single day, that has to bring knowledge. Even if it doesn't seem like it applies, stuff has to translate.
Oh yeah,
like, you got to learn stuff from that, right?
Yeah, we've actually found, we found different like bushing type materials and different things just through working with some of these different industries. We're like, hey, that would lend itself really well over here, and so it's allowed us to kind of push the envelope and expand into different ways without using the tried and true things that get used time and time again in our industry.
That's cool.
I like it.
I do too.
It's cool. I can see where it'd be fun to do. Do something just
look at these little bitty guys.
Just a little guy.
Little coil over. I want one. Like, can I make a keychain out of that?
You could, right?
I'm sorry, I gotta play with this. So that's literally like a little coil over shock.
Oh, that's funny.
That is so cool. I might have a go-kart or something that needs some of those.
Yeah, there you go.
I love it.
I like that. I like that little bitty guy. So is all these, so you guys already made all that, and then is this just the only assembly place for specialty projects like that?
Correct. So that station right there was purpose built to install the spring onto that coilover. So the machining operations that we saw, that's already been done. The anodizing's already done, and then the assembly's already done. That's kind of the final packaging portion of it.
Is that a special project area, like stuff like that, versus where the others are more automotive? Is this when you get
that's
something?
a good question. It kind of varies depending on which department and what group of individuals are needed for that.
I gotcha.
So again, one of the benefits of not having different rooms is we can kind of move these stations around
As needed for the project. Oh, that's cool.
So
that's cool. What are you thinking?
I'm watching what he's doing. He's taking that. This is assembling them, I'm assuming.
Yeah, that's what
and then he's testing them, looks like, over there maybe.
Is that testing?
Is that a test?
Yeah, so that machine is actually built to install the spring
This machine
on there.
here?
Yep.
And then
exactly.
he's putting it over here and doing something. It looked like maybe he's testing the spring pressure or something.
It's actually.
There he goes.
That's a good question.
He's doing something.
I think it's a final validation. I'm not 100% certain, but I'm going to go out on a limb and say it's a final validation that everything is seated correctly prior to that, because the shock's already been dynoed, right?
Okay.
The springs have already been checked. So that's more of a final, let's make sure everything's seated and everything's good type of station. But that's a really good point. This is kind of the back side of the shock assembly. So we've built the shock, we verified the shock is built to its specs and what it needs. Well, now what we have to do is we have to install the right bushings, the bearings, the instructions, all those different areas. We'll combine all of that right here and eventually make its way to where it's in a box and all set for you. So
yeah, that machine makes it easy too.
Yeah.
I put those bushings in without that machine.
Yeah, it can be a pain. So having some automation built in, it helps the team, right? Because we used to run everything with a manual arbor press, and that's fine. But without the right fixtures and whatnot, that can be kind of frustrating. But we've actually built then again some more pneumatic type systems, and that just makes it easier for our team.
And so they don't just build the shocks; they actually develop and build machines to help build the shocks.
Oh yeah,
which makes for a better product.
That's cool.
Well, and a lot of times that machinery is a way for us to build a process that cannot fail, which is a interesting kind of shift in mindset from a QC standpoint over the years, where a lot of methodologies were to build quality into the product through inspection. And inspections are still really important, still get done quite a bit. But one of the things that we focus on now is how do you build a process that is unable to fail, right? So we might build a piece of machinery that is very repeatable, or we'll oftentimes on the packaging standpoint, we will build a scale and a validation check where if that scale is off by the smallest amount, it will throw a red flag, so someone needs to go back and look.
Oh.
Do we forget a washer? Do we forget a bushing or something, small? Instead of having someone go through and have to audit those pieces each and every time, we'll build a system that, again, is hard to fail.
It's just all quality control, and it's just like almost no control to it because they've got it worked out so perfect.
That's one of those where if you open people, it happens, mistakes happen, but if you open a product and you put it on your car and then you go out and now the customer has to, they don't have that makes such a big difference when every single thing is tested. That's a huge thing.
In our world, we got to take that thing out of the box, put it on a car, and it's got to work.
And trust that it's correct.
That's it. I mean, you've got to have what they're doing to make our life work. I mean, we may have to use that shock like right now or whatever it may be. And if it's got a chance of failure, the bigger chance of failure, the bigger chance of us failing. So theirs is all proven right here.
That's impressive.
Such high quality control.
We've all been there, whether it be at the racetrack or 9 o'clock on a Friday night and you're doing that installation. Missing that washer or that specialized, we'll walk down this one, that specialized nut or bolt or whatever it is, that's frustrating.
Yeah.
And again, we've been there. We're car people. We understand.
But that makes a difference because you guys are car people, so you've been in that spot.
Well, it does make a difference. I mean, people don't understand that. I mean, there's just some companies out there that aren't car people.
Yes.
Stop.
I understand that there's a lot of good stuff surrounding me right now.
There's a lot of inventory, And it's interesting because we've taken an approach, right, where we want to make sure we have parts on the shelf so that when you order, we can get it sent out right away for you.
Yeah.
But also, our team is working really hard to make sure that we have the right mix of component level inventory on hand, so that at any given point in time, if demand spikes on a certain item or we needed to build a certain run of whatever the part might be, that we have the right mix of components on the shelf to allow us to do that.
So that way it's not not everything on the shelf. You can modify and adjust as you need, but there is stuff ready to go. I got you. Okay.
Absolutely.
I got to know, who's the genius that came up with the packaging for these shocks where you fold it backwards and pull the shock?
Oh, the core view?
Or was that? I love that way you guys pack that shock.
So we work with different packaging kind of specialists, if you will, but that core view, is a really nice presentation. It protects the shock, right? So you shake it around, nothing's going to move. But when you invest in a quality part for your car and you open it up and it's wrapped in sometimes what feels like newspaper, that's not a really great open box experience, right? You open this up, you're greeted with a lifetime warranty card. You got all the everything presented really nice for you. This makes you feel really good.
Yeah.
And most importantly, I don't have to find a knife or a razor blade and cut that away.
Exactly.
That's my point.
It just unfolds.
It looks like it's vacuum packed, which is
does.
very annoying. It's wrapped around the threads and the knot. It's not in this case.
Yeah.
You just fold it backwards and pull the shock out.
That's right.
The dude was a genius. I mean, he really was.
So it's again a really nice presentation.
That does make a
keeps
difference.
the shock safe on its way over to you, and again, most importantly, when you get it, you just feel good, right?
Well, we pay attention to packaging, really. I mean, the nicer the box, the nicer the part inside that box is probably going to be.
So this is our new strut, and as an example, that's what you're greeted with.
Oh yeah, I
right?
like that. Nice and laid out.
Everything's
See
laid
what you're
out.
getting.
It's also, kind of like we're talking about that QC check. If we are missing something in here, it's really easy to see.
It's a visible.
It's a very visible
check,
piece, yeah.
Is that a Mustang strut?
That's a new Mustang strut, yeah. So this would be like your S197 platform that this would fit. But we go back all the way to the Fox body as well.
We need to make some competition for some
That's
other strut
right.
people out there.
That's right.
I also like that you guys still print instructions. I do not like having to go.
And the team that actually writes the instructions is the same team that's answering the phone.
Oh, nice.
Which
Okay, that
is-
way they're familiar with it.
They're familiar with the parts, but also they can anticipate where there might be a stumbling point
Right.
during the process. and they can anticipate that and work that into the instructions.
Nice.
And if there's ever a spot where maybe something could be explained better and they're getting calls on it, well, guess who controls the destiny on making that better?
They get less calls. That's a big incentive right there.
So that's something
cool.
we work on, quite a bit, is that open box experience and that experience you have as you install it on the car.
Huh,
That's
awesome.
important.
So-
It really is.
Yeah.
I mean, I read instructions sometimes. It's like I'm reading the words. They're English. I understand them, but they don't work together. I don't know what
I did that
read.
just the other day.
Yeah.
I called you about something we were installing at the show, and I said, these words, there's like 25 pages, and there's way too many words for this to make sense.
I remember that.
Yeah.
Because I said I've done the
Yep,
exact
same
same
thing.
part,
Yep.
and it's like there's so much instruction, and it's so poorly written that it was miserable.
Yeah,
you know?
so that makes a big difference. Big
It does.
difference.
So the guy that's answering the phone, if he wrote the instructions, he's going to change it.
Oh yeah. It's a nice motivator for sure. So this area over here, we saw a lot of parts being lasered over on the other side, some CNC operations happening on the other side. This is our welding division right here. So we have a mix of both manual welders, but also we have some robotics mixed in as well for some of the high volume repeatable tasks that we're doing. But if we step in here, this will kind of give you an idea of what's taking place in this area every day. So we might be doing new cross members. This is for like the F body. We're doing upper cross members. We're doing control arms, as well. So we'll be doing, different things over here. We're cleaning everything up before it goes to powder coating. So we have a full cleaning station. Could be doing motor mounts. We're doing a pile of motor mounts, it looks like today.
Nice.
But this area stays very, very busy. Mostly MIG. We do a little bit of TIG as well, depending on what we need to be doing at any given time. But this area is very, very busy, and all types of parts coming through this area.
So
these
this
days.
is just basically the hand welding. I mean, manual
All hand welding,
right
yeah.
here. Somewhere else is your CNC.
Yeah. Over this way, I'll show you, is where we have the robotic activities happening.
Didn't see you guys there.
So we have 2 robotic welders. We have one here, and then we got one over here that's running right now. And
Size of those machines.
this will show you, really the extent of, how far we can really take a product. Now that might still be hot, so
I'm not grabbing it.
actually you're good for the most part. But this is a full cross member for our C10 pickup. So, this will not only show off some of the engineering and thought process that goes into it,
yeah. Okay.
but you look at the fit and finish and the quality,
Yeah,
it's phenomenal.
Yeah.
And again, that's going to make it perfect every time. There's
Yeah.
no human error in that.
Well, I was just looking at him, like this piece right here, I feel like is combining so many of the different processes we just saw over there. It's a good example of it.
Bending, the laser cutting, or like, so the hole's actually lasered. That's not stamped.
Correct, yeah. We don't do much for stamping, a little bit here and there.
That's kind of almost old school at this point, isn't it?
With what we're able to do with the laser, we can all combine it into one op now instead of having multiple ops. We might do some stamping similar to what you see down here.
So you do that in-house as well?
Correct, yeah. That's more decorative. But also, one of the things that our engineering team is striving to do is how do we make the parts not only perform, but make it aesthetically pleasing as well. And so there's little subtleties that we try to incorporate into the design that just kind of elevate it just a little bit.
Now,
So-
will this be powder coated before it goes to customer, or
Yes.
do you guys sell any that are unpowder coated, where it's like the customer can choose a finish, or do you powder coat everything?
Great question. We will powder coat most everything unless there's some welding required. And so some of our cross members, like for the F bodies and some of our Mopar applications, you do need to do some welding up where it meets to the frame. But we will powder coat everything in between and then leave the ends raw.
Oh, really?
Yeah. So it's kind of a hybrid approach because we want everything to look really good for you and feel like, hey, this is going to be a good piece for me when I go to install it. But we'll leave just those ends raw, so you just have to come back and touch up a couple areas.
That's interesting. So like that, that's a good place for a jack,
Yeah.
That's a nice
Exactly.
fit right there. for a
Exactly.
Nice padded jack.
So
Yeah, that's a nice piece. Mandrel, or not mandrel, but CNC bent square tubing. So instead of cutting and slicing like I might do, that's all perfect.
No, I assume we're going to get there at some point, but you guys are constantly finding new markets and areas, and are you doing all that R&D in-house?
all R&D gets done in-house. Yeah, we'll check it out before we're done yet, but that's kind of our playground. That's where we come. Basically, our engineers, we're driven to solve problems, right? So we identify a problem that's either not been met in the marketplace, and we'll go after it, or we're coming up with new ideas and ways to kind of stretch ourselves in the way that we approach things.
Or make something better, like an S197 Mustang strut, right? You know,
Totally.
there's a reason to build it, even though there's other people building them. They can build. They see an area for improvement.
Yeah. Well, there was something the other day, and I don't remember this part specifically, but we were at the show ordering parts for an upcoming project, and they said something. I was like, QA1 doesn't have that. They're like, yeah, they do. It's like, I did not know, because it's just something. It was something new that I had just found, and it's funny because you guys are there's constantly something new.
So that's actually so Melissa, we were talking with earlier, our president and CEO. That's one of our company top line KPIs we look at is the business that comes from new products. And her mindset is, if we fall complacent or if we just kind of fall back on what's worked yesterday, well, then we're going to fall behind. So we need to constantly be innovating, and by keeping that as a top line metric for the company, that keeps us coming up with new ideas or finding new problems that need to be solved or finding areas that we can expand and grow and stretch ourselves.
What a team, huh?
So,
I need people like that.
yeah, it's a great motivator for sure.
It's amazing.
Yeah, they certainly can.
They're loading parts in there.
Yeah, so what's happening right now is we're actually loading up that fixture, basically kind of like a dry assembly of what we just saw all welded together. And this welder is really neat because this entire table is going to turn 180 degrees. So actually the welding takes place on the other side, and we'll go back there. But the head of the welder will actually come in and weld from different angles, but then the table can turn as well. So to get all 360 degrees, basically a sphere of that entire part.
So all the welds, all the way around each tube and everything is done in one fixture. It doesn't have to come out and flip over. And
I don't believe we have any fixtures where you're going to come back and hit it a second time. We might do some tack stations in some cases, but we'll try to modulate everything through one fixture. That's going to be, a focus when we design that part. So again, we're not trying to double handle, any of these parts. So that's what we focus on.
So if you ever get a customer that says that doesn't fit my C10, for example, we know that it does. Every one of those is in the same fixture. Your C10 doesn't fit the cross member. I mean, if there's ever a question, because that's fixtured up and you know it fits across the chassis.
Yeah, that's a really good point. And, let's face it though, you take a truck that could be 50, 60, 70 years old, things happen to it over the years, right? And so a challenge that our engineers have is we need to design parts that can actually bolt on to things that might have moved around over the years.
Not
like
just
control arms have twisted a frame, so you build that into.
Not just like from the factory stock location from that point in time. Right, okay.
And something that happens is actually, like the C10 is a prime example, is when you unbolt that subframe or the cross member, you'll actually get the frame rails will actually spring. So sometimes you might have to use some ratchet straps or some creativity to pull them back together. That's not a fault of the truck, it's just how it was assembled and how it was used over the years.
So no need to panic either, because when it's put into this cross member, when that's installed, it's going to be right again.
That's right, it'll draw it back in and you'll be fine. So,
and somebody might panic. I mean, there are people out there that says, it won't fit now, and my old one came out of it. Pull it together and it's going to be in the proper location.
That's right.
Don't get panicky.
But these parts they install with ease. I have one of these in my personal C10. I have a 72 C10. But we do installations, not only on the employee vehicles from the R&D standpoint, but we'll do quite a bit as well. So there's the table turning. And if we come around this way,
well, one's being welded, they can pull one out and fixture another one. What?
So that's cool. One of the benefits.
Well, yeah, and then on the other side, it's cool because they're able to be getting another one ready while
They're
this one's
still
welding.
working while he's working. So it's not, you know, the robotics thing can be viewed a couple different ways, but it's the same part, same quality weld every single time. It's not really taking anybody's job. There's somebody over there doing it. It just makes it so much more precise and consistent.
Yeah, that's cool.
It's awesome. Well, he's burning some rock. Listen to that.
And we try to select the products that we're doing with the robot based on either high volume or they're very repeatable tasks. Our team is still extremely valuable where that human touch is really needed. So that's something we try to focus on. But, you know, like we were talking over in the other area, you know, this machine here needs so many operators to work. It actually creates jobs versus the initial perception of taking jobs away.
That makes sense. It's more for repeatability of the part. It's not even necessarily saving money by saving operators. It's just for quality of
It could be quality, but also fatigue on the team, right?
I mean, welding is boring. I've welded all my life. Just sit at a table and do the same thing, that part every day, one guy doing it. You know, at some point the guy's thinking about the beach. And it might not be, this guy never thinks about anything else. He's doing the same thing every day. And I don't know if that's saving any money, it's making quality.
Now I want to see a robot at the
cheap machine.
No.
Now I want to see a robot at the beach. I said now I kind of want to see a robot at the beach.
No.
I would love to.
No, we don't want to.
Dennis is done.
That's my favorite thing on the car. As much as I like the shocks, every time I take the drive shaft out of the car, I look at it and go, what a piece. What a piece of art. I mean, it just blows my mind.
Now, there'll be a whole separate video for this because some of you guys will remember from Sick Week, we had an incident. However, I can tell you it was a very freak deal, and that's part of the conversation we've had is like they wanted it back so they could see what happened. So we'll get into that later, but
every part has to be R&D field tested, and that's what we're doing. I mean, it doesn't mean the part's bad. It means that we found a weak link in it.
But if you think about it though, you know, you take a drive shaft, right? So this is actually a filament wound process that we have going on right now. But you take something like this, and you know they're designed for cars, you know, a couple thousand horsepower. We get a lot of guys and gals like you guys are pushing the limits of these products, and you know sometimes, you know, leaving hard on a trans brake, you know, things can happen.
yeah.
But a drive shaft like this designed so that in the event you do have an issue, it doesn't hurt the car, it doesn't get into the cockpit, it keeps the driver safe, which is most important. And I know you experienced that, and you're back and running by the end of the afternoon.
Well, that's one thing that we were actually talking because we have a race coming up. We haven't changed it back yet. I actually do not feel safe. He said, I don't want to run the steel. I was like, I have no desire to run the steel drive shaft that we have because when something happens, that just, poof, you just get a little itchy.
Yeah.
Smell a funny smell.
Exactly.
And it's fine. Everything's fine.
Exactly.
There's so much to be talked about with that.
We're going to do a whole video. Like this will be
So you don't want to get into that right here?
No, this will be a whole video because honestly, we take that thing in and out, in and out, in and out, again and again and again because we have 7 other problems that are actually the issue, and then this one's the least of our
It doesn't
concern.
just connect things together.
Yeah, exactly.
So I get to see it a lot. You would think that you put it under the car and leave it there. Not for us.
When you get in the 6-second zone, every part gets handled a lot. I mean, they don't go together and stay together.
No, so we're gonna do a whole video on that. So you guys check back. That'll be the next video because I want to do a whole segment talking because you guys correct me if I'm wrong, but I remember hearing at one point your final balance is with the sticker. Is that correct?
Yeah. So there's such little mass to these drive shafts that our final validation is oftentimes with that sticker. We don't add weight back to the drive shaft with like washers or what you're accustomed to seeing like on an aluminum or steel one. We'll dimple with a drill press. We'll come in and we'll just take a little material off and then finally round things off with the sticker itself. So
Yeah.
it's pretty incredible
crazy.
what we do there.
That's a lot of precision.
So
we'll come back to this. Okay,
Yeah.
drive shaft world. We
So-
have different worlds here at QA1. Drive shaft world, shock world.
I like it.
We're
I
dubbing
like
it. Okay.
So I got all the background and fiberglass. That's what we did for so
Yeah.
long. This is very fascinating.
That's a cabinet.
Yeah,
of
and the
carbon
neat
fiber.
thing, you know,
Oh.
so a little history on this. So the carbon fiber drive shaft division for QA1 really started, it was Jim Jordan, Melissa's father, who really kind of pioneered the idea for QA1 to look at, you know, again, stretching ourselves and innovating in some new and different ways. And advanced materials was one of those areas that we looked at. We're basically neighbors with 3M, being up here in the Twin Cities. They had interest in doing a resin for a commercial application along the same time as we were looking at doing something for the motorsport world. And so we worked together with their aerospace and transportation division, come up with the resin and some of the processes over the course of several years, and developed really what you see today. But we start with really carbon fiber windings themselves. Like actually just right here, this will give you an idea. This is how every drive shaft starts for us. And we'll do the filament winding right here in house. So
That's
So crazy.
cool.
yeah, and we'll have, you know, what's pretty wild about this is your wall thickness will range, you know, 080, 120 wall, somewhere in that range. But that's what design, and I mean, we've had people pushing 4,000 horsepower successfully with them. I know you ran them for a long time without any issues.
Oh, yeah.
And
Because your guys' the wind pattern also changes for the application, correct?
yes, yeah.
Okay.
So, you know, some of the drag applications will actually design it so that it gives a little bit of a twist. So when you leave, it doesn't shock the tire quite as hard. And we've actually seen people pick up their 60-foot just with switching to a carbon fiber drive shaft, and that's something they comment to even too, a little bit more subjectively, but that kind of see the pants of, hey, it doesn't feel quite as harsh as it did through the shift points or different other things.
But that's intentional.
Intentional.
That's cool.
Yeah.
I like that.
So drive shafts are a tuning device.
I remember when you first told me all that, and it was super. I was like, this is
Yeah.
some magic going on
Do
here.
you actually make different wall thicknesses, or you're saying
Depending on the
that it can-
application, yeah.
So when you set up to do an 80 thousandths wall, it's going to be 80 thousandths.
Mm-hmm.
It's not. It might come out 100 thousandths or 120.
No,
when you
it's-
said 80 to 120.
It's
That's
dead
intentional
on.
stuff. Okay.
Yeah.
Very cool.
Yeah, so I mean, we support drag racing, street performance, circle track. You know, so different applications require different things, and it was through a lot of rigorous testing and testing back and forth on different cars to really figure out what's that seat spot for each of them. So
And it's not
pretty
just
wild.
I suppose somebody, maybe there's tube out there that people can just buy and
Mm-hmm.
press some ends in with some glue, and you call it carbon fiber drive shaft. But this thing's really engineered. I mean, there's been a
Through
lot
and
of time.
through, yeah, and you're exactly right, Dennis. I mean, there's a lot of companies that will take a carbon fiber tube that was commercially developed for any given use, slap some end yokes on it, and call it a drive shaft. We take a complete opposite approach. We'll design it from the filament winding process on up to be a drive shaft right out of the gate. So,
Okay, there's a whole.
She don't want to talk about it. for
No,
some
I
reason. I'm
do.
dying
I
to
do,
talk
because we're
about
gonna do a whole.
it. Okay.
I already-
you
I
wanna
have an
go
idea.
do the rest
So
of
stay
the plan?
tuned.
We'll come back
Yeah,
to
stay
that.
tuned. That's the next video. There's a whole. I want to do a whole section on that. All right, so there's plenty of science that's going on with drive shafts here. So I think it'll be a whole nother video. We can come back to it and.
I'm really
Say
not
that.
good with that. We're right here. I really like this process. Let's talk about it.
kind of
Let's
with
do it.
Dennis here. We're here. We just got to talk about it, right?
And
We
with
don't need
that,
all that extra video. Let's just talk about this bitchin' drive shaft.
and with that, I have been outnumbered. So we shall continue to talk. Take it away.
All right. Well, you know, again, so we saw the actual carbon fiber
Yeah.
winding process,
Yes.
right? But you know, this is the tube. This is what we end up with after we wind that mandrel behind us here. But what we do is we start with actually a filament winding process, right? So we're starting with the raw carbon fiber that goes out on the spindle. It does get absorbed then with the resin, gets wound. It's all the tension is maintained on there through a variety of different computers, making sure that it's doing the same thing every single time. And we can wind that in a way where we can set that torsional stiffness, which is really cool, especially with drag racing, because one of the things that we try to do is we want that drive shaft to twist a little bit, helps the car leave a little bit better, it's not shocking the tire quite as hard, and it's a really awesome piece.
Now, can you have somebody, if they say, because I know you say you can use it as a tuning device.
Yeah.
So if somebody comes back and says, I'm experiencing this problem, can you change your pattern to help tune with that, or is that not?
Typically, we'll have different drive shafts with different intent, right?
Okay.
So we might be doing drive shafts for like a dirt race car, might be for drag racing, street performance as well. So we've kind of dialed in for the different applications already right out of the gate, what works best in those different scenarios. Not to say it couldn't be taken to that next level, but typically that's going to be a much more involved process, instruments on the car, and really going to that next level.
I don't offer drive shafts that have, you know, I want more twist in my drive shaft. You're not going to do that. You sell me a drag racing drive shaft.
Correct.
Based on our horsepower.
You got it. Yep.
Which that makes sense. But do you?
It's going to be different than a circle track drive shaft.
Correct.
Right.
Yep.
Okay. So I have held the drive shafts many times, QA1 drive shafts many times. However, I've never held it without ends. The weight difference on this is incredible. That's a super light tube.
It's so precise. It's so amazing. And that gets into that sticker right there, throws that thing off balance.
Yeah.
I mean, that is the balancing method, not this.
Yeah,
but
there's such little mass there that, you know, we do, instead of adding weight to the drive shaft as we go through and balance it, we'll dimple the end yokes a little bit, just take a little bit of weight away, and then the team puts their final stamp of approval with where that QA1 sticker ends up. It's pretty amazing.
One of the things that I really liked about this when we first put it together, we could see the drive shaft spinning behind us.
Oh, yeah.
We had the gear vendor in, so we'd drive down the road, and I'd look back there, and it's like, this thing is perfect. I mean, it looks like it's sitting still. It's not. And I've been in lots of cars with steel drive shafts, and we have one now, and you see just a little bit of harmonic.
Yeah.
And you know, they just don't balance out like these things do.
No, and that's one thing. Carbon fiber has a natural, basically shock absorber aspect to it. It just dampens the NVH. I have one in my own truck. It's like 65 inches long. It's a long bed C10. And I noticed just the shift points were a lot smoother. When you left really hard, it just felt so much smoother, and it's because I can absorb that.
It's winding up like a rubber band on an airplane.
Exactly, yeah.
So.
And I can also say something that is interesting is we have, when we were running our gear vendor, sorry Rick, when we were running that multiple times and we had this in and out, I was so scared of it at first for nicking it or anything like that, because we're having to move it around bars and you know, everything, and I'm like, don't want to breathe on it. And then by the time it was all said and done and we got to where we were taking stuff in and out a lot, I got a lot less timid with it. And like, I know you still have to be cautious with it.
We never nicked it, but I think what you're saying is it's tougher to nick it than you thought.
Yeah, that's what I'm saying. Like, I was scared of nicking it or like just letting it even like barely touch anything. I was very surprised that I didn't hurt it, but it's not that weak.
You know, we need to get you around the dirt late models and see what they do to these drive shafts. You'd be amazed. I mean, it's basically like being a sandblaster for, you know, a couple hundred laps in some cases. And, you know, those guys will run them, and it's nice because you just wipe it off when you're done and it looks clean. But that's a testament to the 3M matrix resin. So when we designed these drive shafts, we worked with 3M, local here in Minnesota to us, and they had joint interest in developing a resin for a commercial application alongside what we were trying to do with drive shafts. So we needed something that, you know, didn't absorb water. We needed something that was really abrasion resistant, and we needed something that was extremely strong. And they helped us collaborate and develop that resin both here at our facility, and we spend a lot of time at theirs. So
that's cool.
Rock chips and things like that, it's a non-issue.
That's awesome.
It's tougher than you think.
Yeah, absolutely. I guess like our little ding is nothing compared to a rock flying at it in the middle of. But that was loud. With that said, something to highlight real quick. Mention we sent our drive shaft up here from the 55. Really cool as you guys are looking at it and seeing what actually happened, because I can tell you, we abused the last one really bad.
Yeah, the first one that we had in there took a lot more abuse, a lot more broken parts in front of it, a lot more tire shake. You know, we had to develop the car through that drive shaft, and it's still together.
Yeah. So we'll get you guys an answer when we find that out. But that just got back pretty recently to you guys, and so working on getting a new one wound up now.
That's right.
And have it ready. So we'll get back on that when we find it. But it's cool because they actually want to look at it and see what caused it, why.
Yeah, and right now, I mean, you know, the verdict's still out there. We're trying to figure that out. You know, you guys have a badass race car, right? You got a lot of torque, leave on a trans brake, and you know, sometimes things happen. Mm-hmm. But the biggest thing though is carbon fiber drive shafts design. The failure mode is it doesn't hurt the car like you'll find with steel and aluminum. It doesn't enter the cockpit. Doesn't take the tail shaft out the transmission or destroy a bunch of other things. And so I think that's a testament right there that it did its job as described, right?
Yep.
But there's still a lot of work to be done to figure out what we can be doing better.
Yep. So we're gonna figure it out. But the cool part is, all it sounded like the rods kicked. However, nothing was actually damaged. We were able to get it back together. So I can tell you, I don't feel halfway as comfortable currently with a steel drive shaft beside me. So I'm ready to get that swapped back out.
Yeah, it's one thing to take a drive shaft out, lose a pass or whatever. It's another thing when it comes through the car and takes your side out.
I really don't like the idea of any kind of pain. I'm in the wrong sport for that, but this helps with that. So, all right, after this, what is going on? So you guys wind them, you get the tube, and then where do we go?
Yeah, so we do the winding process. That goes onto a mandrel. We have a large oven right here. That's where everything is heat treated and taken care of. But over here, this is where we're going to do a couple different operations. We're going to cut the drive shaft to length so that it's meeting the specs that you call order form. And then we bond the end yokes to it. And then when we're done with that, we have our high-speed balancer over here where, again, we have a drill here that will come in, and this will actually drill the part, take a little bit of weight away. Once that process is done, we'll do our final indexing with the sticker, get it boxed up, and get it to a doorstep near you.
Oh, that's cool. Okay, so from start to finish right now for a custom order, you guys you said like 2-3 weeks-ish?
Typically a couple weeks, that's pretty average,
nice.
right?
Okay.
The process is a little bit different, a little more involved than just
It
running
made
down
it
the
sound
street.
simple, right? Yeah.
Exactly. Then running down the street to your mom and pop's drive shaft shop is a little bit different, right?
Yeah.
But when you it's a really nice piece. It's something that it's a shame to put a body and a car on top of it because it looks so good, right?
That's a fact. So when you're winding the tube, you cut it to length. Do they all wind the same length and then you cut from there, or?
Good question. They'll typically be, I think it's a 12-foot mandrel that are being wound. So depending on what orders we have queued up in the system, we might do a couple drag race drive shafts at the same time. One might be shorter or longer than the other, but really kind of what is coming down the pipe for work that's needed. So kind of varies.
Okay. That's pretty cool. Okay. You ready to go to the next section?
Yep, let's go.
On to the next?
You want to see where we design parts?
Yeah. Let's go there.
So, we're back here designing all types of things. Even little tiny cars.
That's what caught my eye when I walked in.
So this is something I want to say we're in our probably 4th year doing, but we've actually partnered with our local school district, and we do a program with them called Engineered for Speed. We've actually worked with SEMA and gotten some different grants, and then we help out. But we donate some of our time, equipment, energy, engineering folks, tech group, but we'll actually go and teach the different students, different principles around aerodynamics, about different things that help make cars go fast, and then translate that to how then their real world experiences and maybe their schooling and how that might translate to something that could be done in a career path for them over time. So it's something we're passionate about. There's more and more instances of tech classes and different opportunities to be hands-on, getting out of the schools, especially at a younger age.
Right.
And we're trying to bring some of that back to the school districts. And Lakeville is one of those districts that is really passionate about the idea
That is cool.
to get people excited about cars.
You never know, that little piece of wood could change a kid's life. I mean,
Totally.
He gets interested in aerodynamics or weight, and stuff, and he never knew he wouldn't have the opportunity otherwise. And,
Right.
I mean, it could make a career choice.
What
yeah,
kind
totally.
of age group is that? Did you say?
So the grade, I think it's 4th grade primarily that we're working with, and
That's
then the
cool.
high
It's
school
like-
gets involved too, and they might do some of the, they've done some 3D printing for us, they've done some of the laser work for us as well. So again, we try to engage different students at different age ranges, but it's been something that's been really fun for the company to get behind. And again, I think we're in our 4th year right now doing it.
That's cool. Dad always he talks about he had shop class and everything that. And like where we were at, we didn't have shop class. We had agriculture
Oh, sure.
farm
Yep.
class.
So you got to
Yeah.
arc weld with a stick,
Yep.
and I had everything: machine shop, welding
Totally.
shop, wood shops, auto shop, body shop. So I understand how valuable that is.
Yeah.
Some people might not, but this is creating generations to come of engineers, and thinkers.
Yeah,
Yeah.
that's
Gonna
cool.
make these
That's really cool.
awesome parts.
Yeah, so then we grow up and we build stuff like this, right?
You guys have a theme going on, are you?
Yeah, there might be an F-body theme
see
taking
that.
place right now. So, you know, we take cars, we bring them in at various states, right? So it might be an old clapped out, like 3rd gen like we have here that we brought in because it allowed us to 3D scan everything really nicely and see kind of what the packaging requirements might be for a new product. And then gradually we'll bring in nicer and nicer cars as we start to hit the road with them again and do some different things. But the design engineering group will start with understanding, okay, what is a problem that needs to be solved out there, an unmet need from our customer base? And we'll start with a platform like this, start getting some of the initial packaging and requirements understood. And then the design engineering team will be working with our product development group to then come up with different variations of the product and then work its way through validation, not only from validating a process out in manufacturing, but working with test partners all around the country to bring you the parts that ultimately end up on people's cars everywhere.
And tested, I mean, it's tested and proven before it's sold.
Yeah.
That's right.
I mean, they're out there road testing and
That's cool.
endurance testing.
So when you normally start on a new product for, say, a body that or a style that you haven't done, is this a common theme where it's like you're saying the different stages? Is that a common?
Yeah, that's not all that uncommon for us. We'll start with something that it could be just a chassis. Like when we're doing all of our classic truck suspension, we brought in a lot of bare frames, and then running and driving trucks started making their way in, and then we would reach out to people that had no relation with the project whatsoever and have them install it and test it. Get feedback and make sure that we weren't overlooking anything, because we have our blind spots as well. So it's that third-party validation that is most critical, kind of that final stamp of, yeah, you guys nailed it, or hey, this is really good, but what if you tweak this or that? So
That's cool.
That's
yeah.
really important.
That's cool.
we do a lot of that.
How many people are working back here?
Our engineering group, and well, to be honest, the group that's back here, it could be 30, 40 people at different phases,
Okay.
right? So you have your engineering team, they're going to be involved at various stages. Our product development team will be coming back and installing different things. Our tech group, who are doing the instructions, they'll be back here doing different pieces of it.
So it's not just like a dedicated one crew back here
No.
constant. Oh, that's cool. That way it's an in and out.
No, and
That's neat.
Sometimes it's really hopping back here, and other times it's
Oh,
like,
yeah.
no, it's-
yeah, it's quiet back here. Guys could be in a meeting or could be doing different things right now, but it really varies. So, but this area stays very, very busy, doing different things at different times. They might be fixturing up something that, I'm not sure. This might be to maybe stress test
it's got a load cell on it. So
Yeah,
there's
torque arm
testing
maybe?
something, yeah.
is
that
maybe a
you're right.
guess.
Yeah, I think so.
So, a lot of times if we don't have a piece of equipment, we'll go out and build it ourselves. This is an example of one we're working on.
So that, because I came from a scale background as
Yeah.
well. So for a few years, I actually made scales and service scales, and that's a load cell, electronic load cell. I don't know where the wire's at on it, but anyway, they've obviously got something in here to stress test something. So it's, it takes a pretty special organization to go to this level to prove that the part's what they think it's going to be. For us, if I built it, which I did a lot, I put it on and tested on the track or the road or whatever. They know before it ever goes out of here that this can handle that. That's impressive.
Hypothetical.
Yeah, when in doubt, just add wall thickness to it. That's something that a lot of people tend to do.
Look at this. That ain't no
He likes
battery. I like
likes
it.
flashlights, guys.
So I use a lot of them. As I get older,
It's the small things in the world, right?
Yeah, this is like Nicky
There, you got
Bobby
your Christmas
world.
gift figured out.
Flashlight. Yeah, I've already thought.
That's what I'm doing.
Yeah.
I'm hinting.
So, but yeah, different projects at different states right now.
Cool.
One of the cool things is, we're going to have a mix of vehicles. So, actually these two Camaros are here, this 3rd gen, and then this beautiful 69 that we have here. This is a couple of employee vehicles that,
Nice.
again, we'll tend to look internally first when it comes to R&D, and test different things. And our team is quick to raise their hand when a project comes up.
I can see why.
Yeah, exactly.
cool.
So get those wherever we can. We got a couple over there for transmissions as an example. But we have to test fit all these different combinations, and then the worst part of it is all the header configurations that happen.
Seems like a nightmare.
Do you run this with some Nova headers, or it really varies. But through this area, this is where a lot of the design engineers are doing things all throughout the day, designing parts. They're hopping back and forth to the shop, testing different things. So these guys stay really, really busy.
So do they design, and then also are they the ones that's like, so whoever sets up the program for the robot welder and stuff like that? Is that all in here, or is that elsewhere?
We have kind of a separation in our team between the design engineers and the manufacturing engineers.
Gotcha. Okay.
So people who are programming the robots to do different manufacturing ops, they'll tend to be more on the manufacturing engineering side, but also a little bit of crossover here and there where it makes sense.
I gotcha.
So, it's always good for the design engineers to get a little bit of perspective of then how it's made behind the scenes, and then vice versa. So we'll work on that quite a bit as well. So
that's cool. There's
you seen some top secret stuff over there?
I guess I didn't look close enough. I must have blinked when it happened. Is that a top secret project? Okay, I was like, oh no.
I'm trying to figure out why he's working on a 9-inch ring gear.
Well, if like a lot of the parts that we're looking at, if like the torque arm needs to mount to a 9-inch, we need to have those models in the system and kind of look at how we might interface to the bolt pattern that's already there or different pieces. So most likely what's taking place on that front.
Huh. This is a smart room right here.
This is a smart room for sure.
It's awesome though.
This is the part that I don't like when we do it.
I slightly enjoy it. I actually do. I just don't have time.
I've got one little bitty CNC mill, and when it comes time to program a part, there's my programmer.
There you go.
So she does that. It's like, I can and I have, since the beginning of that stuff, the old days of it, but I don't enjoy it. I like hands-on, and so
totally.
I fixture and I machine and she programs.
Well, a lot of time gets spent to picking out the right hardware for something, what length bolt or what grade bolt or what type of head do I want on that fastener. Like, there's a lot of time and energy that goes into that thought process.
And for us, it's a team. So, I understand one side of it and she's better at the other side of it because of the experience difference. And your guys are doing that. They're designing there and going out there and checking measurements or see if it's actually going to work. So they're kind of their own team.
Yeah, they got it.
That's right.
They got it all. Oh, safety glasses.
Then we'll poke our head in our lunch
Let's even show the weather.
Quick.
Just in case they forgot.
Yeah. Just in case you didn't know it was snowing.
In case you didn't. Oh, you guys have a contest going.
Yeah.
Northern, thanks.
So then this in here, this is our break room essentially. One of the things, we were talking about this earlier a little bit, but we want a really comfortable spot for our team, right? When it's not snowing a foot on us, we'll open the garage door and get some fresh air moving through here.
Nice.
There's some food and beverages. People want to grab something throughout the day, but just a comfortable spot, right?
Now I'm
like
thinking
this.
shop stuff.
I for real, I walked in and the first thing I thought was, this is cool. My shop could use some of this
Do you
stuff.
have an area in your shop we could do this?
Not for this size.
I like it.
Kinda.
Yeah.
But no, that's a big deal because happy people have to make a lot.
parts.
Happy parts.
Well, totally, yeah. And again, you spend so many hours of your day and your week and, coming to work, and it's like, I want to feel good where I come to work, right? And that's something we've worked really hard is really build that environment. So
I've never had that job.
You've never had that job?
No. I'm sitting out in a dirty shop eating food.
You can come visit my shop.
That's what I'm asking.
Okay.
Do you have room for that?
No, there's a good point to this because when we lost the shop at HRG for 2 episodes, we went from like this really nice bar area with a refrigerator with every kind of hot sauce you could think of. It was great. And then we ended up in the cold dungeon with darkness.
You had to suffer for 2 episodes.
We did. But it made a big difference in the crew's personality going. And then now we got a shop
totally.
again. Everybody's happy. This was a great week at work
Yeah.
this week.
She called me and she goes, everybody's grumpy. Everybody's mad. It's not fun anymore. Because it wasn't, they had this, a countertop.
We had a nice
and
area,
refrigerator.
yeah.
we had a sink.
Had a sink. We had a sink. Yes, we left that, and then now everybody's great, super happy this
Yeah.
week because we got a nice area. So big
But
difference.
it makes all the difference, and we'll do different things too to have fun throughout the year. I mean, we'll do beanbag tournaments or different things.
Oh, fun.
Cornhole type.
Yeah, exactly.
Games and stuff.
Yep.
Yeah.
Yeah, little tournaments.
Cornhole. Yeah, that's what I thought it was.
But yeah, we'll do all of that.
Is that where you have the car show out here?
Yeah, so a few times throughout the summer, we'll do a big cruise and we'll take people on a 100-mile road trip. Get a chance to enjoy your car, and we'll fill the parking lot. Actually, not all that different to like a staging lane at the drag strip. We'll pull in 200-300 cars and stage them, and everybody hangs out, checks out people's cars for a little bit, and then goes on a 100-mile road trip with 200-300 cars. It's a lot of fun.
That's cool.
How far is the drive up here? We may have to come up for one of those.
Oh, that'd be fun.
Casey and I have discussed this idea for a couple years.
My cab over would be, it's got a lot of QA1 stuff on it. It would be awesome out here.
What day is it this year?
Open house is July 19th.
July 19th.
That's with Street Machine Nationals.
That's one day before my birthday. It'd be a celebration.
We'll throw a big celebration here. We'll have all of our car friends come.
Done.
We'll get a cake and
I'm
everything.
in. All right.
Okay, we may be back, guys.
So my cab over has to be running by my birthday.
Okay.
Okay.
That would be awesome.
Plenty of time.
Yeah.
It's pretty close.
It really is.
It's pretty close.
I think, it's kind of like in Hot Rod Garage where they have the TVs going with all the Motor
Yeah.
Trends. They just have parts instead of TVs.
Yes.
Yeah.
Well, they got TVs too. They got it all.
I didn't even look up that. That's not important to me.
This is interesting. What is this?
So,
I don't know.
one of the things that we look at as a company is, we follow EOS, Entrepreneurial Operating System.
Okay.
And so there's some theories and different education we bring to the team of, again, what are the things that you're most passionate, qualified to do, and what makes you unique or special. And so it's just different things that we try to encourage for the team to be thinking about. This will give you an example idea here of, what we do for our open house, but we packed that parking lot full.
You did pack that parking lot full. Wow.
And so if we do a dentist celebration birthday thing, I can be like right here and we can have a
Oh
cake
yeah, totally.
here.
Well, the dunk tank for you will be over
Oh,
here.
okay.
I like that.
That's the story of my life.
Yeah.
Hey, it's still a celebration of a dunk. Okay.
But there's the grand tour.
That's a lot going on.
There is a lot going on here, that's for sure.
So
That's
the
for
best
sure.
part about all of this is this was an incredibly long video
Thank you.
because there's lots of good stuff happening here.
Thank you.
And I got a whole iPad of stuff that we're gonna go back and visit. So, how long was this video, Meg?
Probably an hour.
Awesome. We love it.
There we go.
People like it. So, okay, where's Dad? Hey.
Are you filming? I thought you were done.
No, we're talking.
Oh, I was sending Mike Bell a picture of that Dodge truck. It's his thing.
Okay, so with that said, I think we can wrap up here. Are you good with that?
Yeah, I'm
Good
good.
with that?
Well, no, I could spend a lot
We're
more
going-
time.
In the gymnasium.
Actually, we're not done. There's one more spot. There's one more spot. So I asked them earlier, I said, what's up here? Because look, it's a curtain. You'd think a secret project, something crazy. Well, there was something crazy. It's just not what I expected. So they're like, oh, it's a gym. It's a gym. I'm like, oh, okay, there's some equipment. And then look at this. Just wait. I'm going to show you what my face looked like. So they're like, do you want to see what's out here? No steel toe shoes. Sticky floor.
It's like a mousetrap. Like fly paper.
It's a basketball court. It's a whole basketball court. QA1 branded basketball court, okay? Is that what you expected?
That's it. I was blown away. Look, you can play basketball and watch them make shots. How cool is that?
Again,
had
we gotta
to
keep our
redo
team
the-
Oh,
happy and healthy, right?
I literally went, what?
So if you wonder why QA1 stuff is so good, this is the reason, literally.
Basketball.
I would look forward to coming to work every day. I think I want to move to up here.
Up here.
Yeah.
Where's it going?
Yeah. So what happened there is I get Michigan and Minnesota and Wisconsin. I get them all confused.
I tried to say it earlier, somebody asked me where QA1 was, and I said, cold. It's north.
Yeah.
Because I do the same thing. I get them all mixed up because I guess it's so close to everything.
Oh yeah. Well, we're dumb.
We're not familiar with up here.
We're challenged, geographically challenged.
Yes. Okay, so as you can see, there's a lot of cool stuff hidden and sprinkled in here at QA1. It's a much better place to end this video, but we're not done. There'll be another video come after this with some more in-depth good stuff.
And we need to watch you shoot some baskets.
And we're gonna watch Dad run up and down the basketball court and dribble.
No, I think she's going to be the one shooting basketball. That's going to be the thumbnail. I never played basketball. See, we're not a ball family, unfortunately. I don't play baseball either.
He says,
I don't know. I don't know how many goals it takes to win basketball.
Yeah.
I don't know which racket to use. All right, guys.
You laugh, that's true.
With that said, that is a wrap for this video. Thank you guys for the tour.
Of course.
I appreciate it. Thank you guys for watching. Link to QA1 is below in the description. Check it out. And don't forget, come back because we're going to deep dive into some of the stuff that was out there that you saw. As always, be happy, go fast, and stay pretty. I will see you guys next time. All right, today we are at QA1. Behind me is all kinds of greatness in manufacturing, assembly, technology, and all that. But best of all, there is a QA1 basketball court. Ready? So good. Oh wait, hang on. Good. We tried.